Okay, guys, so we're going to look at how to do this experiment measuring waves, wavelength, and frequency. So this is the presentation I gave you. I wanted you to look at wavelength and frequency of waves, and we're going to then do an experiment to measure that. Now, obviously, we're not in class, but even if we were, this would probably be something we can't do easily in the real world because it's hard to freeze the waves to measure them. So this simulation is useful even if we were in class. So we're using a simulation called Waves Intro. And what we're going to do, this is showing you how to use it, is we're basically going to start dropping water into this tank. We want to have the drops on continuous, so they keep dropping. You can see the waves instead of just one drop. We want to look at the tank from the top. Currently, I think it's the side, and we want it on normal speed. Over here with the variables and tools that we're going to look at, these are things I'm going to show you next. We've got our tools, that's our measuring tape, that will measure velocity, and this will measure the heights of different waves. We can change the frequency, so how often that drip happens will change how often the waves go through their cycle, and the amplitude is how high the waves go. Okay, so that's the idea of this. Let's just have a look at this. Okay, so measuring wavelength. So we're setting it on, we want a side view, so we're looking at the water going up and down, continuous drops. We're going to have the frequency in the middle and the amplitude up this high. So second from the top. Okay, so let's actually go and do this. If I flip, I know I've got lots of stuff on here. Here we go. All right, so water. So we want continuous, we want side view, and leave everything else as it is. So when this is happening, you can see every time the drop happens, it pushes the water down, and then the water, its elasticity, causes it to bounce back up again. So you're seeing a continual drop of water, and you can freeze this here. So you're seeing continual waves happening. The change in the water level is the wave, and the energy from that wave is going from where the tap is all the way to the edge of the tank. And what's really changing is the water level is going up and down. So our first activity, still lit, then 5 drops or so, basically so they get to the end, then hit pause, it doesn't matter how many, and then I believe we need the measuring tape. So measuring tape tool and measure across the crest. Now it said 2.6 there. I wonder if it's going to be the same now. So let's try and get the middle there. Oh, sorry. Maybe I have to I'm just trying to remember how to do this. That one there, then click this end and move it across to the top of that wave. And it says 2.7, which is very close to 2.6. That's probably just my measuring error before. So with this frequency and that amplitude, that is the wavelength. And so I would go back here. I've measured it. That's all I wanted you to do for the first activity. The second one, we're actually going to change the frequency. So let's try this now. We'll move the frequency up and see what happens. Now you can already see it in my picture there. Let's move the frequency up one. Oops, and we're going to play. Oops, sorry. What did I do? Oh, I turned it off. There we go. So you're noticing the drops are happening more frequently. That's what the frequency is. It's changing the water level on a more frequent basis. So now let's see how far apart the waves are. Well, you'll notice that they're smaller than the ones I had earlier. So I might need to, so let's put that in the middle there, bring this one across to here. It's now about 2.3, okay? That's the distance of one wave, the wavelength. Okay, my frequency has gone up, but my wavelength has gone down. And that's the key thing to notice here, okay? So you'll notice that if I move the frequency up, it went from 2.6 to 2.4. Same thing, it went from 2.7 in my current simulation to 2.3. Okay, so this answer here should be the wavelength has decreased. It has gotten smaller. Okay, that's all we had to do there. So a lot of this was really not writing as much, it was doing stuff. But I know some people have trouble with doing these things, so that's why I'm videoing it for you. Okay, activity 3, if we take down the frequency, what will happen to wavelength? Now you've already seen one thing, so you can actually make a prediction here, a hypothesis. When the frequency is decreased, what will happen to the wavelength? Now, when I increase the frequency, the wavelength went up. Oh, sorry, the wavelength went down. When I decrease the frequency, what would be the opposite? Well, we would assume the wavelength will become longer. Okay, we'll find that out. So we're going to set it up. This time, again, we're changing the frequency. We're going to move it down, just down 1. Same thing we did before. So let's go back here. Oh, sorry, leave it on. And sorry, we'll take this down to there. Now you're noticing the drops are happening further apart, less frequently. Okay, so that's the idea, that the water level is changing less frequently. So we have a lower frequency in this change. So let's freeze it there and let's have a look at how far apart it is. Now 2.3 was that other frequency, so let's go to here, 3.0. Okay, so it was about 2.7 in the middle and now it's 3.0. So that's longer. The wavelength has become longer as my frequency has gone down. That's all we had to do here. Okay, and you'll notice that this is the same as what's on my screen. If you actually weren't able to do it, you could have watched what's on these screens here. Okay, so changing the wavelength, lower frequency, higher, longer wavelength. Okay, so when frequency was decreased, the wavelength increased. Did you predict that? And if you didn't, that's okay. If you didn't know what was going to happen, that's also okay. Sometimes we make our predictions to kind of see if we understand it. It's a check. It is not you being told you know stuff and you don't know stuff, okay? Because science is all about learning things. So you've done the second one, a third activity, sorry. Okay, so the last thing was a bit of recording now. You've played around and you are basically going to change with the simulation to change the frequency of the waves and measure them. And I didn't make you do every number, but I made you do a lot of them. We already did these ones, so you really only needed to do at a frequency of 1, frequency of 2, frequency of 9 and 10. So let's go through and do that now. So let's start with the frequency of 1. So let's take it all the way down to the first little tick there. And let's go play. You can see how much that's dripping there. Now I need to stop it here and let's measure it. So let's put that one in the middle of that wave. You notice I'm measuring from crest to crest here. Okay, so that's 5 centimeters. So with frequency of 1, the wavelength equaled 5 centimeters. All right, let's go to a frequency of 2. Now we're going to give it a moment to just catch up and the waves to become from that. It's hard to tell, it's a little bit faster, but let's see. So from the middle of this wave and we go to the middle of this wave and now we have 4.3. 4.3, is that accurate? It's hard to tell. So, you know, I gave you, there's always a little space for a bit of different numbers. So 4.3, so that's at 2, 4.3 centimeters. All right, next one. We were up to, we did those. We're going to do 9 and 10. So here's 9. Yeah, we already did the others. Oops, leave that on. Look at all those waves. It's dripping really quickly. So here, we'll put that on that wave. And let's go to this wave just here. The first wave across, 1.7. So at 9, the wave is 1.7 centimeters wide or long. And then we move it to 10 and we see again. Give it a few drops. The number of drops is not too important. It was just as a way of making sure you had the right drops on the screen. So you didn't still had the wavelength from number 9. So now it's 1.7. Wasn't it just 1.7 before? It seems to be 1.7 again. Let me just let it go for a little bit longer. From there to there, yep, 1.7. Okay, so it was pretty similar between the last two. I wasn't sure what to expect. I would have expected a bit smaller, but maybe it's just too hard to measure. Oh, here's a 9. Maybe I didn't measure 9 properly. See, go back, double check, 1.8. Okay, so if 9 is 1.8 and 10 is 1.7. All right, I'll put these numbers in, but while we're looking at this, we can also put down, we can measure the number of waves per cycle. Here, 1, 2, 3, 4, 5, 6, 7, 8. Oops. Okay, so I measure that at, I stop this at 8 cycles. So if I get my time period, which was 7.6, and I've got 8 cycles in that time, that would be 8 divided by that 7.67, and I should actually end up with the number that we had there. This is how we calculate frequency. We look at the number, 8 divided by 7.67. And it says about 1.04. So maybe my measuring is not so great. Oh, sorry, and that would then tell you the frequency. That's what I'm measuring. Okay, so that tells me the time period, and that then tells me the frequency. Okay, so let's stop there and let's go back to our table. Okay, so with this, we've done it. We need to finish these answers. So this is my answer one, and I'm going to put in the answers that I found. So wavelength. At 1, it was about 5.0. At 2, it was 4.3. The other ones are there. At 9, it was 1.8. At 10, it was 1.7. Okay, so there we go. There's my results for this. Now I just have to put in the last bit. So wavelength is the length of the wave. The length of one wave, to be very specific. So not just any one wave, one cycle. So one wave, let's put cycle in as well, cycle. Frequency is of waves per second. Okay, so we didn't actually have a value for frequency there, but we could figure it out if we count how many waves went through, were formed every second. So really in this case, how many drops there were per second. Which is why I did drops divided by how many seconds I had. So 8 drops was about 7 something seconds. So when frequency is increased, the wavelength decreases. And when frequency is decreased, wavelength increases. Okay, so wavelength gets longer, decreases, gets shorter, increases, gets longer. Okay, so what I'm going to do is upload just the answers for this activity online and the video so that you guys can check your work and see if it makes a lot more sense to you now. Thank you.